I can understand that many of you are already familiar with normal distribution, and I have given you a brief on it. Normal distribution, actually in statistics, we don't have something called normal distribution. Normal is very recent or very new name. In statistics, it's called the Z distribution, or it's called the Gaussian distribution, named after its inventor, Carl Friedrich Gauss. So in statistics, academically, we call it the Gauss distribution or the Gaussian distribution. So why they call it normal distribution? Because simply the normal distribution is the most recognized continuous distribution in statistics. What does it mean, this phrase? It means that whenever you have a process with a continuous data, whenever you have a process with continuous data, time, weight, length, height, blah, 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 this process by 90% or more will follow the normal distribution, or follow the Z distribution, or will follow the Gaussian distribution, Gauss. That's why it's called norm. The term normal distribution only appeared a little bit more than 100 years. Again, we in statistics academically, we know it as the Gaussian distribution, or the Gauss distribution, or the Z distribution. So again, why it's called normal from a little bit more than 100 years? Simply because it is the most recognized continuous distribution in statistics. What does this mean? You have already understood yesterday what is the meaning of a continuous data. Continuous data. So whenever I have a process which have a continuous data, number with digits, 1.2, for example, something like this. Thank you, Dr. Kulsoom. Whenever I have a process with a continuous data, by 90% or more, it will follow the Gaussian distribution. That's why we call it normal, because this is the normal. The normal status that as long as you have a continuous data, you will follow the normal distribution. So from here came the name normal, but actually in statistics, nothing is called normal. When using variance, I can't understand your questions, Amal. You will always use measures of variation, but you will never use a variance, as I have said. Variance will just be used on academic papers. In business, you will not be using variance at all. You are using the standard deviation and another measure of variation, which we don't have time to discuss it here, called the interquartile range. But for this free course, you can use only the standard deviation. So if you are talking about data analysis or the application of statistics in business, you will never use the variance, but you have to understand it because it's underpinned a lot of tools. And also you will never use the range, but you have to understand it because sometimes it will appear in control charts, for example. This is my short answer for your question. You will just be using standard deviation, but you have to understand range and variance because they will pop up a lot in other tools you will be working with as a data analyst. But when you are presenting findings, when you are analyzing things, the measure of a choice will be standard deviation. So what is present, or what can I do when I have data which is non-normal, skewed, like, for example, if you remember this shape, something like this, or something like this. It doesn't follow the Gaussian distribution. As I already said before, don't panic, no problem. There is a branch of statistics called nonparametric statistics. And this is the first thing, one of the first things I talked to you about in today's lecture. We can classify statistics into descriptive and inferential, and we can classify statistics into parametric and non-parametric. So simply, no panic, don't panic. There is no problem if your data is not following the normal distribution or the Gaussian distribution. Simply, we have a complete branch of tests in statistics called non-parametric statistics. So no worries. Wherever your data is, or whatever, sorry, your data is, normal, non-normal, Statistics has a solution for everything. So how can I assess normality? Why I need to assess normality? Because in every test I'm about to do, I have two options, whether to go with the parametric statistics or to go with the non-parametric statistics. So a normality assessment is very important because you need to understand beforehand whether you will go with parametric or non-parametric statistics. And this is one of the objectives or one of the benefits you gain today by understanding the measures of central tendency or the measures of location. I said that if the mean and median and mode values are very close to each others, it means your process is centered and it will follow the normal distribution and you can follow the parametric tests and vice versa. If the mean, median, and mode, and specifically mean and median values are far from each others, it means you have shifted process and you will not follow normal distribution and you can apply the non-parametric tests. So you have already gained the importance of playing around with the measures of location or the measures of standard central tendency. For sure, we have something called normality test. This is some sort of advanced technique. We don't have time for sure to explain it. But in statistics, we are not sufficed with just looking about centered and shifted, look about the mean and the median. It's okay, it will give us an idea. But to make this clear cut, we have in statistics something called normality tests or test of normality, which will give us a clear-cut answer whether I will follow the normal distribution or not, whether I will go for the parametric statistics or not. But we don't have time for sure to discuss this today. Also, part of the descriptive statistics will always be about graphing and visualization. So you can say that descriptive statistics itself could be split into two subtypes. First, numbers, which is measures of location, measures of variation. Second, it will be graphs. So the purpose of graphing is, for sure, we have a lot of benefits from graphing. First, we can identify potential relationships between variables, like something called the scatter plot. We don't have time to explain for sure every graph in details. I can identify the risk in meeting critical needs of the customer through a plot called process capability. We can provide insight into the nature of the X that may or may not control the Y, something we call the optimization plots. And above all of this, it will make the analysis simple for presentation purposes. When you are presenting findings to non-technical audience, whether they are middle management or top management, and they don't have any idea about statistics, it will be much better for them if you showed them some graphs, not only some solid numbers. In our course, we are not in this free course. In our course, we are covering a lot of, for sure, a lot of graphs, like box plots, like histograms, scatter plots, dot plots, time series plots, individual value plots, optimization plots, and more. And I think that most of you are aware of the histogram, for example. This is the histogram, one of the graphs we are covering. And as long as most of you are working in the quality, so for sure you know what is histogram is. I don't need to go through it. The second part of the descriptive statistics is the inferential statistics. We classify statistics into descriptive and inferential. Then we took descriptive statistics and divide it into measures of location, measures of variation. Now we'll speak briefly about the inferential statistics. As I said before, inferential statistics will give you a clear-cut answer. You are not compile with the target because 1, 2, 3. You are not stable because 1, 2, 3. You have a lot of variation because 1, 2, 3. So it will answer any why you may have in your brain or mind. So inferential is just an adjective of the noun inference, and by dictionary, inference means the act of process, or the actual process of deriving logical conclusions from premises known or assumed to be true, the act of reasoning from factual knowledge of evidence. What does the bullshit means? It means you have a population and you don't have the luxury, as we said yesterday, to work or to collect all the data about your whole population. So you are just taking sample on condition that this sample will be representing your population. And I told you why yesterday. And you will generalize what you have done with the sample into your population. This is the academic or the official definition of inferential statistics or inference, in particular by dictionary. Inferential statistics by Wikipedia simply to draw inferences about the process or the population being studied by modeling patterns of data in a way that accounts for randomness and uncertainty in the observations. Again, what all this bullshit means, it means that again, you don't have the luxury always to work on a population, so you need to draw an inferences about the population, but using a sample in condition that sample or your sample will represent the population, taking into consideration the risk of the sample may not be representing the population, which called in statistics uncertainty. This is a very advanced, for sure, statistical context. We don't have time to cover it in just 2 days, but if you took the course with us, or if you have an idea or read a textbook, you will understand how I can collect a representative sample from the population and how I can incorporate the risk of uncertainty, means sample may not be representing the population very well, even if you have done, like I have said, sample size and time frame and the subgrouping and so on. Still, from a statistical point of view, still you have some uncertainty. I can't say that sample is equal 100% to the population. And we can take this uncertainty into our consideration when we are analyzing the data. So statistics take care of everything. No worries here. I will not go through the 5 steps approach to inferential statistics. We are running out of time. So to sum up, whether it's a descriptive tool or an inferential statistical tool, these tools will answer very specific questions, which you may face in your work, whether in quality or in business or whatever, supply chain, whatever your industry, service, manufacturing. A use case for some tools is provided in the next slide. So whatever your industry, whatever your role, we have a very customized roadmap in data analysis. So for example, and without details, because every tool requires at least 5 or 6 hours more than the time of our course, I just give you some quick hints. The process or the question of, thank you, Danishan, whether I'm conforming to target or not. I see more and more organization just take a sample and take the average and to compare the average to a target. No, sir, it is completely incorrect. And against all the rules in statistics. And I can give you a lot of whys, but inside a course, not in a free course. The solution will be process capability. But believe me, if you just, when you as an organization want to see if you are conform to a target or not, and the process as it is, you just collect a sample and take the average of the sample and compare the average to a target. No, this is completely incorrect and misleading, and I can prove it to you, but I don't have time here. The question like, was my data collected properly? Even if I have followed your steps or your criteria, sample size table, the time frame, the subgrouping, is there an statistical tool which may assure to me that I have a representative sample? Yes, something in statistics called power and sample size. Is it all about sample representativeness? Which means that, does it mean that if you take a representative sample, does it mean by necessary that all of your problems in statistics has been ended? No, no, sir. If you have a representative sample still, you have some other problems. Something we call it in statistics MSA, measurement system analysis. Still, you may have variation from devices and from people who are measuring. Again, any measurement process have only 2 scenarios, whether a device or instrument is making the measurements or some people are making the measurements. A quality officer is calculating the number of completed medical records. A quality officer is checking whether the prescriptions are good or not, blah, 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 blah. Only two options, human body or device. In both cases, the device may be measuring with a lot of variation, and the human body also as well may be measuring with a lot of variation. So it is not all about sample representative or not. We have something called measurement system analysis. We analyze your measurement system, whether it's a device or a human body, in order to understand whether your devices or your people are measuring with a huge variation or with a low variation relative to a certain standards. Practical